Hey everyone! Welcome to this section dedicated to message history and chatbot memory. In the previous section, we introduced the ChatOpenAI object, explored the system, human, and AI message classes, delved into the magic of prompt templates, mastered implementing few-shot prompting efficiently, introduced the invoke method, applied it on prompt templates and chat models, presented the basic LLM chain, and showcased token usage retrieval. You were, however, left on a cliffhanger. How do we implement our chatbot so that it remembers the dialogue? I'm pleased to announce that we'll explore precisely that now. But before delving into the memory classes LangChain offers, let's explore a convenient way of storing chat history. Here, I've opened a new Jupyter notebook and have prepared the usual environment variable setup. I've also imported some necessary classes: ChatOpenAI, Chat Prompt Template, Human Message Prompt Template, and LLMChain. Chat Message History is the new class we'll now introduce. Pause the lesson, add the class to your list of imports, execute the cell, and then initialize the chat object in the subsequent one. In the next cell, initialize a new object named background info and assign it as an instance of the chat message history class. It includes a parameter called messages, which by default is set equal to an empty list. Let's add a couple of values to it. Type background info and access the addUserMessage method using the dot notation. As the name suggests, the purpose of this method is to append a human message to the list. Note here that the argument must be a string. I'll use the following. Can you give me an interesting fact I probably didn't know about? On a new line, apply the equivalent addAIMessage method. The message I'll add includes the following. Sure, did you know that the longest place name on the planet is 85 letters long? Run the cell and display the background info object. The messages list is now populated with one human and one AI message. We can extract this list by typing backgroundinfo.messages, which will be helpful in just a moment. You may question the need to define a chat message history object instead of merely using a Python list for storing human and AI messages. The advantage of a class instance like backgroundinfo includes such extra features as converting to various formats like JSON, dictionaries, or schemas, quickly clearing chat histories with the clear method, and integrating it with a LangChain memory object, as we'll explore in the upcoming lesson. All right, back to our task. Let's create a template for a user's follow-up question about this place with a long name. Define a message template human variable of the human message prompt template class. As demonstrated in the last section, apply the fromTemplate method and specify a string template. I'll use a simple one consisting only of an input variable, follow-up question. Now let's combine the list from background info with message template human in a single chat prompt template. To do so, construct an object called chatTemplate as an instance of the named class. Apply the fromMessages method, and since it expects a list of chat messages, pass the backgroundinfo.messages list as an argument. To add the message template, follow up with a plus sign and the message template human object inside a list. Recall that when applied to lists, the plus sign concatenates them. Studying the chat template object, we find all three messages in place. The hard work is done. What follows is to create the chain object as an instance of the LLMChain class, with the chat and chat template objects set as arguments. Let's now test if the model considers the background information. In a new cell, define a response variable and invoke the chain, passing a dictionary as an argument. Set the key to the input variable, follow-up question. Set the value to a question of your choice. I'll go with, what is the name? Execute the cell and observe the output in the response variable. Let's extract the value of the text key and print the string out. Sure enough, the chatbot reveals the name implied by the context, the current longest place name in the world. I learned that this New Zealand hill is commonly referred to by a much shorter name, Taumata. Great! Keep in mind that this exchange between a human and AI is the only context provided. Let's pose an additional follow-up question. What does the name mean? The chatbot now responds by first telling us the name, indicating that it doesn't recall having previously shared this information. So, the chat message history class is suitable for situations where we need to manage history messages outside a chain. When recollecting messages from the current conversation, we should instead turn to memory classes, a topic reserved for the upcoming lessons. See you shortly! Hey everyone! In the previous lesson, we successfully provided a chat history to a chatbot, which we fed as a prompt. As we confirmed, however, the ongoing conversation was not preserved. In this series of lessons, we'll explore several of the most frequently used memory types in LangChain and apply them to our chatbot one at a time. One way of logging a new conversation, probably the first that would come to mind to any developer, is to store the new human and AI messages with the old ones, and then feed the entire conversation to the chain on the next invoke. We'll apply this simple technique in the next few minutes by utilizing LangChain's ConversationBufferMemory class. Let's get to work. In a new notebook, I've prepared the usual setup: configured environment variables, imported necessary classes, and initialized the Chat OpenAI object. Apart from the usual ones, we'll need to import two more classes: Messages Placeholder and ConversationBufferMemory. Let's also add the following import. From LangChain.globals, import set verbose. The setVerbose function does precisely what its name suggests: display the output in a verbose mode. Therefore, when we execute our chain, we'll see the chatbot's final response and the intermediate steps. This allows for better monitoring of the process and helps with debugging. To activate this verbose mode, however, we should call the function and pass true as an argument. All right. In the bottom cell, let's create an instance of the system message class, instructing the chatbot to answer questions sarcastically. I'll directly paste the code, since the syntax is already familiar. I'll also paste the definition of the message template human object, created from a simple string template containing only the input variable, question. Our next task is creating a placeholder for all intermediate messages we log. LangChain provides a convenient class called Messages Placeholder. Create an instance of this class and name it Message History. This class comes with a parameter called variable name. Set it equal to the string message log. We'll see shortly where this string comes into play. Incidentally, message log is just one option. Feel free to use any text you prefer. Let's now define a chat template variable as an instance of the chat prompt template class and apply the FromMessages method. As an argument, pass the message system, message history, and message template human objects inside a list. Bear in mind that order is important, as you'll discover later. Run the cell and display the chat template variable. We find that it expects two input variables, message log and question. Okay, in the last lesson, I mentioned that chat message history instances are convenient for feeding context into a memory object. To demonstrate this, let's configure the background info variable as an instance of the chat message history class. Continue by adding a basic user message like, "Hi." Then insert an AI reply that matches the chatbot's sarcastic tone. For example, "You really know how to make an entrance, don't you?" Now that our human and AI messages are stored as a chat history, it's time to create the memory object. But I'll give you a short break and leave this task for the next lesson. Please don't close the notebook, because we'll need it shortly. Welcome back, everyone, to this lesson, where we'll continue the implementation from last time and introduce the ConversationBufferMemory class. Without further ado, let's get to work. Enter a new cell and define a variable called chatMemory, assigning it as an instance of the ConversationBufferMemory class. One of this class's parameters is memory key. Set it equal to message log written inside a string. If you used a different string when creating the message history object, apply that instead. You can now see how the memory key and the variable name parameters connect the memory object with the message placeholder. Next, we must connect the chat history with the memory object. The parameter that will help us achieve that is called chatMemory. Set it equal to our chat message history instance that we called background info. As easy as that. Note that the parameter name, chatMemory, is not connected to the name we've given to the variable. The names happened to be the same. All right. Finally, for this object, let's configure a Boolean parameter called return messages. When set to true, it returns the memory of the chatbot as a list of chat messages. The memory is returned as a single string when set to false, its default value. Let's demonstrate. First, set the parameter to false. To display the messages in the memory, type the following: chatMemory dot load memory variables. Follow this with a set of parentheses and an empty dictionary as an argument. The output is a dictionary with message log being the key and the value being a single string where both messages are stored. We can extract the value of the message log key from the dictionary. Then apply the print function to the resulting string for better visibility. The output is a nicely formatted message. Let's now change the value of return messages to true. The output is a dictionary with message log being the key and the value being a list storing one human and one AI message. Since we defined our template as a list of chat messages, the chain will expect the history to be returned the same way. So let's leave the parameter to true. Now is a good time to step back and revise what we've implemented so far. We first defined an instance of the chatOpenAI object. We then created a system message, a human message template, and a message placeholder, which we fed to a chat prompt template. Additionally, we defined a chat message history object, which we quickly fed to a ConversationBufferMemory instance to serve as context. It's time to feed all these components, the chatOpenAI, chat prompt template, and the ConversationBufferMemory objects, into an LLM chain. Create an instance of the named class and call it chain. Set the LLM parameter equal to chat, the prompt parameter to chat template, and the new memory parameter to the chatMemory object. The final step is to initialize a response variable and invoke the chain. As an argument, create a dictionary with a single key value pair inside, setting the key to question and its value to the following string. Can you give me an interesting fact I probably didn't know about? Remember, question served as the input variable for the human message prompt template we previously established in the code. After running the cell, we notice that we obtain additional log information, thanks to the verbose mode. First comes the system message, then the human and AI messages from the chat message history object, and finally, the human message originating from the human message prompt template. The messages follow the order we specified in the definition of the chat prompt template. Let's now display the response variable, which now stores the question, the message log, and the answer. Retrieve the value corresponding to the text key and print it out. All right, we even have an interesting fact. Go back to the code and apply the load memory variables method again. We see that the response from the AI is successfully appended to the list. Let's now test the memory of the chatbot. Return to the bottom of the notebook and ask the following. Can you elaborate a bit more on this fact? A stateless chatbot couldn't work out what this fact refers to. but ours should infer it from the previous question. Wait for the process to complete and display the response variable. The chatbot provides additional information, considering its previous response. So, we've succeeded in creating a chatbot with memory. Wonderful! For homework, you're welcome to test what would have happened had the order of the messages in the chat prompt template been different. Using the verbose mode, experiment with different scenarios and become even more confident in your LangChain memory skills. Speaking of the verbose mode, remember when we called the setVerbose function with true set as an argument? This line of code sets the verbose parameter of each class to true, where present. In our case, the ChatOpenAI and LLMChain classes allow verbosity. So if you type chat.verbose or chain.verbose, the output will be true. But the logs we see on the screen are due to the chain object, since that's the one we invoke in the code. You can turn verbosity off by entering a new line before the definition of the chain object and typing setVerbose false. All right, I think we've covered enough material for this lesson. In the next one, we'll study the close cousin of the conversation buffer memory, the conversation buffer window memory. See you there! Welcome back. So far, we've learned how to manage chat history outside a chain, studied the conversation buffer memory class, and introduced the global verbose mode. In this short lesson, we'll study the close relative of the conversation buffer memory class, the conversation buffer window memory class. Here we go. First, find the notebook you worked with in the previous lesson, duplicate it, and rename it according to your preference. It'll need only slight modifications. Start by removing some of the cells to tidy up the notebook. Since we'll introduce a new memory type, substitute the already imported one with conversation buffer window memory. Then run all cells up to the definition of the chat memory object. Redefine it as an instance of the conversation buffer window memory class. So, how does this class work? During the previous lesson, you might have realized that prompting the entire chat log is the least efficient way of remembering a conversation. As the conversation grows, the chat model needs more time to respond. Not only that, but it also uses up more and more prompt tokens. The easiest way to remedy this is by enforcing a cap on the number of interactions you allow the chatbot to remember. Once that cap is reached, the messages that came earliest in the conversation are dropped from the memory. Let's impose a cap. For that, we need to configure a parameter called k. You can set it equal to any integer you prefer. I'll use a small number, for example, 2, to demonstrate the effect early in the conversation. Run the cell, initialize the chain object, and then invoke it. Use the same question as before. Can you give me an interesting fact I probably didn't know about? Once we enter the LLM chain, we see the system message, the pair of human AI messages entered as context, and the human message representing the current question. Excluding the system messages and the current question, we have only one human AI interaction, so we're within the maximum limit of 2 interactions. All right, let's now go with a follow-up question. Can you elaborate a bit more on this fact? Studying the prompt, we see that we're now at 2 total human AI interactions, so we've reached the cap. Let's think of a second follow-up. I'll go with, what are other interesting collective nouns? Okay, notice that the first pair of messages, the ones where the user greets and the AI responds, aren't part of the memory buffer. That's because we set the memory object to store only 2 interactions at maximum. Okay, let's do one last follow-up. Can you tell me something interesting about alligators? Now, our first question has also disappeared from the buffer and the chatbot's response. The memory works exactly as expected. You can see that we can't keep this topic for too long, but in some use cases, you don't need to. Additionally, note that the cap did not impact the system message because it's not included in the memory object. This is beneficial, as preserving the system message is generally preferred. So far, so good. These two memory types cover many use cases, but certainly not all. That's why coming up with other techniques is always welcome. We'll dedicate some time to the ConversationBufferMemory class in the next lesson. See you in a bit. Hey everyone! So far, in this section, we've covered the Conversation Buffer and Conversation Buffer Window Memory classes. Recall that as opposed to the buffer memory, which stacks all chat messages from a conversation, the buffer window memory imposes a cap on the number of human AI interactions that can be saved. This ensures that long conversations won't slow down the response time and wouldn't significantly increase the number of prompt tokens. Still, the buffer window memory class has the disadvantage that the chatbot will eventually lose the memory of earlier topics. Furthermore, the buffer and the buffer window memory classes store the original messages word by word, which isn't the most efficient approach for implementing chatbot memory. For example, if you try to remember a conversation with a friend a week ago, you won't likely recall the dialogue verbatim. Instead, you'd summarize only the most essential information. That's precisely the idea implemented in the ConversationBufferMemory class. Let's give it a go. I've prepared a fresh notebook where some part of the code is pre-implemented, namely, the environment variable setup, the imports, note the addition of the new ConversationBufferMemory class, and the definition of the chat object. Let's approach this example differently, working with a string template rather than a series of chat message prompt templates. The string template will include a description of the chatbot, a placeholder for the current conversation, a placeholder for the human question, and one for the AI response. Let's create a variable called template, all caps, and start by writing the instructions to the chatbot. The following is a friendly conversation between a human and an AI. The AI is talkative and provides lots of specific details from its context. If the AI does not know the answer to a question, it truthfully says it does not know. I'll include a placeholder for the current conversation using message_log as an input variable. Let's add another one for the human request and use question as a keyword. Let's wrap up the template by indicating to the chatbot that it's time to respond. Next, define a variable called promptTemplate. Set it equal to the class of the same name. Apply the fromTemplate method, and set the respective parameter to the object we've just created. All right, now initialize a chat memory object. Set it equal to the ConversationBufferMemory class. Since the idea behind the summary approach is to summarize the conversation held so far, one of the required parameters is LLM, the language model that will create the summary. Let's set the parameter equal to an instance of the ChatOpenAI class and leave it at the default model, which, at the time of writing, is GPT 3.5 Turbo. So, now the GPT-4 model is responsible for the conversation, while the GPT 3.5 Turbo is responsible for the summary. Additionally, set the memory key parameter to message_log and return messages to false, since we're working with a string template rather than a list of chat messages. Excellent! If we now load the memory variables from the chat memory object, we'll see a dictionary with a single key value pair for which the key is message_log, and the value is an empty string. This implies that the memory is currently empty. We're now ready to initialize a new LLM chain with the chat, the prompt template, and the chat memory objects as arguments. Let's invoke the chain. Let question be the key and set the value as follows. Can you give me an interesting fact I probably didn't know about? Thanks to the verbose mode, we see we've entered the first LLM chain, passing a nicely formatted string template. Initially, we find the instructions to the model, followed by a summary of the ongoing conversation, presently blank. Next is our query, concluding with the AI's response. Very good. Once a response is generated, we enter a second LLM chain. This time we see a different prompt, beginning as follows. Progressively summarize the lines of conversation provided, adding onto the previous summary, returning a new summary. It's then followed by an example, the summary generated so far, and the new human-AI interaction where we find an answer to our question. The prompt concludes by indicating the model to generate a new summary. Note that this prompt template comes from the ConversationBufferMemory class. For enhanced study, consider copying it from the documentation and enclosing it in a print function to improve readability. Once this second chain is finished, we should have a new conversation summary. Go several cells back and load the memory variables. Indeed, the message log is populated. The GPT 3.5 Turbo model has summarized the interaction. Let's now try a follow-up question. Can you elaborate a bit more on this fact? The prompt fed to the first chain now contains the message to the system, the summary of the previous interaction, the current question, and a placeholder for the AI's response. The prompt fed to the second chain contains the familiar instruction and example, the summary of the previous interaction, the current interaction, and a placeholder for the new summary. Again, let's go several cells up and check the memory variable. The summary is now updated according to the previous interaction. Perfect! I'll stop here and let you explore this memory type at your own pace. Additionally, I advise you to research the Conversation Summary Buffer and Conversation Token Buffer memory classes. Given the memory types we've studied, you should find the other two intuitive. This section's next and final lesson will teach us how to combine two memory types. See you there! Welcome to the final lesson of this section, where we'll demonstrate how to apply more than one memory class in a single chain. But let me first walk you through the code I've prepared. First, ensure you have the usual magic commands in place. Then, import the relevant classes. Notice the last three imports from the memory module. I've decided to work with the ConversationBufferMemory and the ConversationSummaryMemory classes. To combine them, we'd need to import the combined memory class. As usual, I've also created the familiar ChatOpenAI instance. All right, let's now create a string called template. Construct it such that it includes instructions to the chatbot, a placeholder called MessageBufferLog for the past messages stored in the ConversationBufferMemory class, a placeholder called MessageSummaryLog for the conversation summary from the ConversationSummaryMemory class, a placeholder for the user question called accordingly, and finally, an indication that an AI response should follow. Once you're done, create an object called promptTemplate. Set it equal to the class of the same name. Apply the FromTemplate method, and set the respective parameter to the object we've just created. What follows is to create instances of both memory classes following the known procedure. Create an object called ChatBufferMemory as an instance of the ConversationBufferMemory class. Set its memory key parameter to MessageBufferLog and the return messages parameter to false. Similarly, create an object called ChatSummaryMemory. Set it equal to an instance of the ConversationSummaryMemory class. Set the LLM parameter as an instance of the ChatOpenAI class. The memory key parameter to MessageSummaryLog, and the return messages parameter to false. When combining memory types, an additional parameter called inputKey is required for both objects. Let's set it equal to a string holding the word question, since that's our keyword for input messages. Great! Now it's time to combine the two memory objects with the help of the CombinedMemory class. Assign a new variable named ChatCombinedMemory as an instance of the named class. A key parameter for this class is memories, which will store the ChatBufferMemory and ChatSummaryMemory variables inside a list. All right. Let's load the memory variables stored in the CombinedMemory object and ensure they're empty strings indicating that we haven't held a conversation so far. In the following cell, initialize a chain object as an instance of the LangChain class, applying the familiar parameters. This time, the memory parameter is set to our instance of the CombinedMemory class. Perfect! Let's invoke the chain with the familiar question. Can you give me an interesting fact I probably didn't know about? First, we enter the initial chain with the known prompt. We then enter a new chain responsible for creating a conversation summary. Currently, only the new lines of conversation are filled in. Let's go several cells up and retrieve the memory variables. We've successfully stored the first interaction in the message buffer log and a summary of the conversation in the message summary log. Excellent! Let's initiate the chain a second time with the following. Can you elaborate a bit more on this fact? We find the past messages in place of message buffer log and the conversation summary in place of the message summary log input variable. Of course, the question is also added. Let's now study the prompt for the second chain. The current summary and the new lines of conversation are successfully filled in. Let's return to the memory variables one last time. As the text accumulates, it becomes more challenging to read, so let me quickly retrieve the value corresponding to the message buffer log key and print the text out. We see that the last human AI pair is successfully stored. Doing the same for the message summary log key, we ensure that the summary was updated after our last interaction with the chatbot. Excellent job, everyone! This concludes the section on LangChain's memory module. In the next one, we'll concentrate on output parsers. Looking forward to seeing you there!